So an intrusion detection system that we talked about in the previous presentation was automated tools for monitoring our network. But there are also a lot of tools in our toolbox we have for doing ad hoc scanning and ad hoc detection of intrusions or analyzing things that are happening. I want to talk about a few of those tools here. The first set is going to be honeypots, honeynets, and padded cell systems. Basically, a honeypot is a decoy. So it's basically a system that can lure potential hackers and attackers away from critical systems so that they're attacking something benign. And not only does it lure them away from the real systems, so basically what you do is, let's say you've got a database of your customer records. Maybe you don't want somebody to attack that, so you have another database that is much easier to attack that appears to have legitimate data, but it's not really legitimate. And the idea is that that kind of occupies, the attacker, so they don't see the real data until it's too late and you've already been able to shut them down. So that's what a honeypot basically is. A honeynet is sort of an even more realistic scenario because now you create sort of a whole network segment that's completely fake. And this can be completely virtual. But basically the attacker thinks they're in a real network. They think that they're seeing real traffic, but really it's all completely fake. And it's just designed to lure them away from the real prize, from the real stuff on your network. So they divert the attacker from accessing critical systems, collect information about what they're doing so that we can learn from it, and encourage the attacker to stay on a system long enough for us to document the event and respond. So again, we're going to divert them away from the real critical systems so they're not trying to attack our real systems. We're going to use their honeypot to collect information about their activity so we can learn from their activity. We can fingerprint what they're doing. Maybe we can even identify who they are and what they're doing. And they, since they think they've really hacked a system, they're going to stay there longer trying to collect that data. Maybe try to download that 400 gig fake database that we have, for example. So a padded cell system is basically a honeypot that cannot be easily compromised. So in addition to attracting attackers with tempting data, the padded cell operates in tandem with the traditional IDS. So the IDS we talked about before, what will happen is when it detects an attack in IDS, it's going to sort of set up a walled garden for the attacker and move them seamlessly into that padded cell, into that walled garden where they can't do any damage. And it lets them just do whatever they want inside that walled garden until they get tired of it and move on. So that's an example of a padded cell. Some advantages. Attackers can be diverted to the targets that they're not going to damage. Administrators have time to decide what to do. Attackers' actions can be easily and more extensively monitored because we know, that it's a fake system. And anybody who's doing anything in there, it's obviously an attack. They can catch insiders who are snooping around the network. Honeypots, you set up a fake, HR file with salary.xlsx and see who tries to access it. And then tell people not to do that. So some disadvantages, there's some legal implications of using these devices, which are not well understood. Perhaps you've heard of the concept of entrapment, right? So if you do catch an attacker in a honeypot, so for example, with salary.xslx, we might not be able to fire somebody for trying to access the file that we purposely set up that's fake because it's sort of entrapment, right? So what's the legal ramifications of that? Honeypots and padded cells have not yet been shown to be generally useful for security technologies. And an expert hacker, once diverted into the decoy system, might become angry and launch a more aggressive attack against the organization. So there might be some reprisals. Administrators and security managers need a high level of expertise to use these systems. You don't want to get burned because you didn't set it up correctly. You don't want to attract, here's the other problem. Let's say you set up this honeypot that looks like it's got some really juicy data in it. And now you're getting even more attacks on your network because all these attackers are seeing this data available, and they're like, oh, look at this, I can get to this data. So you might open yourself up to even more risk in that case. So you don't want to get burned by that sort of thing. So trap and trace systems use a combination of techniques to detect an intrusion and trace it back to its source, usually using a honeypot or a padded cell, which we talked about. There are some legal drawbacks. Enticement, which is the act of attracting attention by putting tantalizing information in key locations, which I just talked about. And then entrapment, which is luring somebody to commit a crime, which isn't always admissible in court. So enticement is legal and ethical, where entrapment is not ethical. So active intrusion prevention. Some organizations implement active measures. So one tool, La Brea, takes up unused IP address space to pretend to be a computer and allow attackers to complete a connection request, but then holds the connection open. So what they're basically doing is allowing somebody to attempt to attack when they detect the attack, but then they kind of make it difficult to carry out the attack. They just string it along a little bit longer. So they move on to something else. There's lots of scanning and analysis tools. They're used to collect information that an attacker needs to launch a successful attack. So an attacker will use a lot of these tools to try to get reconnaissance about a network, to launch an attack against a network. So footprinting is the process of collecting publicly available information about the potential target. There's also fingerprinting, which I'll talk about in a second, which is a systematic survey of a target organization's internet addresses collected during the footprinting phase to identify network services. So you start with the footprinting, and then you can sort of narrow in with the fingerprinting to look at exactly what's running on all these different servers and figure out exactly what services are running. And again, this is all part of the reconnaissance phase. The thing about these tools, a lot of folks say that, gee, these tools are dangerous. I don't want them on my network. But it's important to be aware of these tools. Number one, that they exist and how they work. But you can also use these tools so you can see exactly what an attacker is going to see if they run these tools, which could help you better lock down your own network. So it's certainly a good idea to use these tools and understand them and keep them laying around. Port scanners is one of those tools. Nmap is probably one of the most famous examples of a port scanner. It allows you to identify and fingerprint computers and what's running on those computers. It's pretty effective, Nmap. You can perform generic scans, or you can look for specific protocols and ports. So you can tell Nmap, I'm looking for a web server, and I want to find out what kind of web server is running on that machine, and it will try to do that for you. And they're actually pretty effective, unless you harden your server. And that's the value in having these port scanners for us in IT security, is we can run these tools and use them to see what the hacker is going to see. And more importantly, once we harden our systems and make our systems into a state that we think is secure, we can verify that state by running these tools to see what information they would find if they ran these tools. So it's good for to run these things and to understand exactly what the attacker is going to see and make sure that we've adequately protected ourselves. You can kind of think of this as hiring a locksmith to install a lock and then telling the locksmith, can you pick this lock? And if they can't, if they have a hard time picking the lock, then maybe we did a good job, right? But the locksmith knows all of those techniques. They have all the same tools that the criminals have. They know how to protect against that. There are tools to automate remote discovery of firewall rules and assist the administrator attacker in analyzing them. So attackers can run these firewall analysis tools to see exactly what the weak spots are in that router, to figure out what type of traffic is being allowed, what kind of traffic is being blocked, and help them craft an attack that they know is going to work through that firewall. Like I said, it's good to, some people say that they don't want these tools on their network. They don't want to know about these tools, but it's important for us to know about them and use them and understand them so that we know what our attackers are doing. So you really do have to use these tools, install them, and understand them so that you can defend yourself and you know exactly how they work. Operating system detection tools will detect a target's computer's operating system. If they know what operating system you have, they know what patch level it's at, they know exactly what vulnerabilities you're susceptible to, and they can craft an attack based on that information. Vulnerability scanners can examine a network for detailed information and initiate traffic to determine what kind of security holes you have. So there's lots of different kinds of vulnerability scanners. Nessus is a good one. We actually have a whole class here at Drexel that talks about how Nessus works and how you can use it to attack a network and understand how people are going to attack your network. And then we have packet sniffers. So a packet sniffer is a network tool that is going to capture packets and analyze those packets. Usually you have to have direct access to the network in order to do that. Sometimes you can do it wirelessly. Sometimes you can do it by plugging into the promiscuous port on a network device, which we talked about in the previous unit. But in the wrong hands, a sniffer can be used to eavesdrop on any network traffic. So it's certainly something to be aware of. This is, again, something that you can detect on many networks. IDSs sometimes can detect these things. And it's good for us as administrators to know that they exist And also, packet sniffers, I should say, have a very legitimate use. Um, we use packet sniffers all the time to do troubleshooting. When you're having networking issues, a lot of times the only way you can troubleshoot why you're having the issue is to use a network packet sniffer so you can see that traffic. So there's definitely legitimate uses for them, but it's important to understand how an attacker could also use those. And of course, there are wireless tools. One of the challenges with wireless is you don't need physical access to a network to initiate a wireless attack. A packet sniffer, you have to have physical access to the network for an Ethernet packet sniffer. But for wireless, you could be outside the building with a Pringles can, which is you can make a highly directional antenna that can work from a long distance, and with a coffee can or a Pringles can, and sit in your car and be doing reconnaissance on networks. So we do have to understand the risk of wireless networks and make sure that we adequately protect those networks. But there are special tools that we can use to sniff wireless traffic, to scan wireless systems, assess the level of privacy and confidentiality afforded on the wireless network. And we do talk about wireless network security in a little bit more detail in IT Security 2. So I'm just kind of giving you a taste of this here, and we talk about that in much more detail in IT Security 2. There are tons of network security tools. I would encourage you, if you're interested in any of these, to try downloading some of these. Nmap is an easy one. You can download Nmap, install it, and start doing scans on your own network at home to see how it works. One thing I would caution you, however, if you're going to try to use any of these tools, be aware that we talked about intrusion detection systems, and many networks will detect that you're using these tools. So if you're at work and you install Nmap and you're not part of the IT security team, you will probably get somebody asking you what the heck is going on. There's a good chance you're going to get caught using that if you're not sure what you're doing. So try to use it in a network that, your own network, where you're not going to do any real harm. So that's my only piece of advice for caution there. And certainly don't use them on the internet. Don't try to do Nmap. Don't try to use Nmap to scan Google, or else you'll find yourself not being able to get to your Gmail account for a few days. So again, be careful how you use these tools. But I encourage you to look at them, figure out how they work, and try using them on your own network. And maybe even try seeing how you can harden a system within your own network to try to prevent the information that you see in something like Nmap. And that's something we talk about in a little bit more detail in IT Security 2 as well.